students out there that's non-traditional that hasn't had algebra in several years. So to make a long story short, I teach to those students that need it, all right? Those of you that invented mathematics and invented algebra and invented calculus, you just sit there and be quiet and maybe come up with a cure for cancer or COVID. All right. So what I'm asking you to do is be patient. This is a review section. I'm probably going to spend the next day, today and Tuesday, on the review section. So we're going to have to move on. But I'm going to try to hit and miss. The first session is on the functions. I started with the ice machine analogy, and I hope that you understood it. Now we're going to move on to compositions and things like that, and we're going to go from there. All right, now with a function, and I showed you that a function was 2x plus 4, and y is equal to 2x plus 4, and this is the input or output. This is the input, and this is the function. Now, back in grammar school and K through 12 or whatever, you were told, you know, that you could add functions, you could subtract functions. Here's a function f of or x plus 2 plus 3x minus 6, and x plus 1 minus 2x minus 3, and x plus 3 times x minus 6, and x plus 2 over x minus 1. Now those are all 4 operations with functions or with expressions, however you want to say it. This is addition, this is subtraction, this is multiplication, and this is division. Now I'll go ahead and tell you the division you can't do anything with, because there's only certain division problems that you could actually work with. Usually the degree of the numerator is higher than the degree of the denominator, so you can work with those. But if you don't have one where the degree of the numerator is higher than the degree of the denominator, then it doesn't work. The degree of the numerator has to be higher than the degree of the denominator. And if it's not, then if it's not, then you can't do anything with it. So I'm not going to worry too much about division too much, because sometimes you can do it, sometimes you can't, and we'll get to that in just a minute. But with these, you just distribute the positive 1 and distribute the positive 1, and you get x plus 2 plus 3x minus 6, and that's going to give you 4x plus 4. And all of you know how to do those. And x plus 1 minus 2x plus 3 minus x plus 4. And x squared minus 6x plus 3x is minus 3x minus what, 18? Okay. You have to watch me with 3 times 6. Sometimes 3 times 6, I'll put 24. So you have to watch me on that.
Hubert, am I dumb, or is the addition one supposed to be minus 4?
Which one?
The addition one? The first one?
Might be. I don't know. Yeah, you're right. Thank you. You have to catch me on some of these. Let's see. Negative 6. Yeah, thank you. Should be a minus. Okay. All right. Now, again, these are all things you did in grammar school, and that's fine. But a lot of people don't make the transition between K through 12 or K through 6 or whatever, K through 8. A lot of people don't make the transition from here to functions. And you have to hold your pinky out, hold your pinky up, and f of x is equal to x plus 2, g of x is equal to x minus 1. And now I'm going to do f plus g of x. And that's going to be what you learned in K through whatever. X plus 2 plus x minus 1. And this is the way that you write a function. As simple as that. Some people say, well, that's just a fancy way of writing y. And it is. Now, some math teachers will not say that. They can't stand when you say that. But it's true. It's a fancy way of writing y. But a lot of students get a hang up about that when they make the transition from these to these. They kind of get hung up. And those of you that hadn't had 109 last semester or 110 last semester or Algebra 1 or Algebra 2, you got to remember that these are expressions. You put a y in front of it, they become an equation. You put f of x in front of them, they become a function. So, you know, that's how it works. So instead of being fancy, you just go back to your roots, and that'll be x, and then, I'm sorry, x plus x is 2x. Whew, I was trying to multiply them. And then 2 minus 1 is 1. Okay? If I have f minus g of x, well, that's going to be x plus 2 minus x minus 1. And that's going to be x plus 2 minus x plus 1. And the x's cancel, and you're left with 3. F times g of x is equal to x plus 2 times x minus 1. And that's x squared minus x plus 2x is plus x minus 2. So you know how to do this stuff, all right? The problem is the transition from expression to equation to function. That's where the problem is. And if you make that transition by looking at what you did back in grammar school or high school or junior high school, and you say, okay, well, we just put a y in front of it, and it becomes an equation, and then we put a fancy f of x in front of it, it becomes a function. So you could say that equation and function are the same thing, because technically it is. All right. Again, I'm teaching to those people that haven't had algebra in a while. Now, here is an example of a division problem that you can do. F of x is equal to x squared plus 2x. And g of x is equal to x. And I want f divided by g of x. Well, that's basically x squared plus 2x over x. And that's going to be x plus 2. Now, will you ever go into long division? Yes, you will go into long division. And I will wait until I get a question on homework. And I do have some questions on homework. We're going to go over them. And they are long division problems. I'll wait until I get one before I go over it, okay? Because most of you may remember and understand long division. But here you could have, I'll give you a long division, f of x is equal to x squared plus 2x minus 3, and g of x is equal to x. And that would be long division because, you know, you could, go ahead, what? I thought somebody said something. Okay, you could do x into x squared plus 2x minus 3, and x will go into x squared. X times x is, hold on, Why didn't it? There. X times x is x squared. X times x is, oh, okay, you subtract, sorry. That goes out, 2x. X will go into 2x 2 times. 2 times x is 2x. You always subtract. And that gives you -3. And -3 is a remainder. So you can have 3 over x plus -3 over x, or you can say remainder of 3. Okay, I'm not going to get into that too much unless I start getting questions on long division in the review. But that's an example of functions. And basically, a function is written f of x is equal to some different equation, just like you did back with the y's. Okay, so there is no difference between an equation and a function other than y is taken out and replaced with f of x. Now, what does the function mean when you got something with it? Well, let's say f of x is equal to x squared plus 2. And you are, then the directions say find f of 4, and then that's A, and then B is find f of x is equal to 6. Now, these are 2 test questions. These are 2 standardized test questions. These are just real basic. What the heck do you do? Well, back in grammar school, or when I say grammar school, I mean K through 8, all right? Because that's when somewhere in there you're introduced to algebra. And the basics of algebra is you take this right here and you have an x here and you have a y here. Now, this says f of x. So that means x is equal to 4. So you put a 4 right there. This says y is equal to 4. So you put a 4 right here. I'm sorry, 6 right there. Now, how did you solve in grammar school or previous grades? How did you solve this? What did you do to solve this right here? That means I want y'all to interact with me.
Plug in 4 for the x.
There you go. Plug in 4. Plug and chug. So 4 squared plus 2 is equal to 16 plus 2, which is equal to 18. And that is what you do there. Now the way that you do it, you say f of 4 is equal to 18. That's what the fancy way of doing it, but you did it back in the 7th, 8th grade when you learned how to graph. What does this mean? Well, this means that y is equal to 6. So this is the same thing as y. So 6 is equal to x squared plus 2. Minus 2 minus 2. X squared is equal to 4. X is equal to positive or negative 2. What is that noise, Mr. Ninegar? It sounded like TV was on or something. All right, so that's how you do composition. When some composition is when you substitute. Okay, so here I've got a 4 in the parentheses. 4 in the parentheses means that I'm going to plug in 4 for x. Here I've got f of x is equal to something, so that means y is equal to 4. So that means I'm sorry, 6. I don't know why I keep doing that. That means y is equal to 6, so I'm going to plug a 6 in over here. Now this brings us to what is a function, or when is something a function? Well, I'm going to go to the next page, and I'm going to show you when something is a function. When is a graph representing a function? I got two graphs here. One graph looks like that. The other graph looks like this. Okay, this goes in red. Red means highlight, so that means get your highlighters out. Check with the vertical line test. Vertical line test is how you can tell if a graph is a function. There's my vertical line. There's my vertical line. If intersect is equal to 1, you have a function, because 1x is equal to 1y. In other words, the x is going to be equal 1x, or not 1x, but one quantity of x is equal to one quantity of y. An x will give you a y. X will give you a y. Notice I underlined a. A y, not 2y. We're over here. X gives us what? Well, you got a y up here. Let's say this is 4, and this is what? -4. 1x gives us what? 2 y's. And this is not, and the paper's not, this is not a function. If a function gives you an answer, it is a function. In other words, 1x will give you 1y. This x right here, let's say this x is 4. And this y is 6. Okay? For each x I plug in, I get 1y. For each x I plug in, I get 1y. One answer. Here, for each x, let's say this x is 2. When I plug in 2, I not only get a positive 4, I also get a -4. So when you have an answer for each x, that is a function. When you have 2 answers for each x, that is not a function. And I'll be honest with you, there's a lot of people that go through algebra and don't know the difference. Anybody got a question on functions so far? Now I'm going to get into the most important part of functions, where a lot of people don't have a clue. And that's composition. And this will be on every standardized test that you take. Composition of functions. Let's say that f of x is equal to x to the second power, and g of x is equal to the square root of x plus 1. Composition means substitution. And students just forget how to do composition because they don't do it a lot. So here is fog, F composed of G, goff, G composed of F, off, F composed of F, and gog, G composed of G. These are the type questions you'll be asked on a test. Find F composed of G, find G composed of F, find F composed of F, and G composed of G. An open circle, instead of, you might think this is a multiplication symbol. It's not. It's an open circle in the middle, and that usually means composition of function. So I'm going to take a blue marker, and I'm going to highlight the F in blue and the G in blue, the F in blue, and the G in blue. That means that wherever there's an F or a G, here a F, I'm going to draw a big set of parentheses. So F with a big set of parentheses. G right here will be the square root of G of X plus 1. This is squared, and this is the square root of X plus 1. So I just drew all my problems. This means draw a big set of parentheses for F. This says draw a big set of parentheses for G, F, and G. Now I'm going to take a different color from blue. Let's see, what is it? Let's go with orange. Orange. And I'm going to circle G, and F, and F, and G. So that means wherever there's a set of parentheses, I'm going to plug in what? G, Hubert. Thank you, class. I appreciate the interaction. So the square root of X plus 1. And this is going to be X squared. And this is going to be X squared. And this is going to be square root of X plus 1. And now you've got nothing but simplification. I want you to take a second while I drink my vodka. Take a second and do the algebra for those 4 problems. What happens when you take the square root of a radical with the, let's make this distinction. Let's take a green marker, and that's a 2, and that's a 2. Okay? What happens when the exponent is the same as the index of a radical? What happens? That again, I want you to interact with me.
Gets rid of the parentheses.
They what?
Everything.
They cancel the radical, don't they?
Yeah, yeah.
So I'm going to take my handy dandy blue highlighter, and I'm going to cancel those out. And that leaves you with X plus 1. So the composition of F composed of G is X plus 1. And the composition of G composed of F is equal to the square root of X squared plus 1. And the composition F composed of F is equal to X to the 4th. And the composition here, take our blue marker, and that's going to go out. And that leaves you with the square root of x plus 1, which is the square root of x plus 2. Now that is as simple as I can explain it. Now I guarantee you, because I was in algebra and I always had a problem with these, I guarantee you there's one or two of y'all out there that's always had a problem with composition of functions. Now you shouldn't, because you take the first one, the first letter, and you draw a big set of parentheses for that function. So x squared. And down here, big set of parentheses squared. And then this letter, you plug in to that big set of parentheses. So I take that x plus 1, square root of x plus 1, and I plug it in to that big set of parentheses. Here, f, I take that and I plug it into the big set of parentheses. And that's how you do composition of functions. Question, gripe, complaint. Anybody ever been confused on composition of functions? Raise your virtual hand if you have, ever. Yep. That is usually what gets students in functions, is the composition. Thank you. You can take your hands down now. All right. So with that being said, let's move on. Let's see if there's any, let's look at those homework questions and see if there's any composition of functions. And let's see, this is R2. So let's look at the homework and see if there's any composition of functions. Oh, wow, look, what a surprise. Tri-County has logged me out. 130. There's a R2. All these are R2s. Okay, so we'll go ahead and check them. Let's see, what comes first? 7 and 59. We've got two 59s. That means that must be a more difficult problem. So let's look at number 7. Oh, that's 75. So 75, that's 77. So let's go with 59 first. All right, so this is R2 59. That is the question in the book. And it's number 14 online. So everybody's 14th question looks something like this. Oh gosh, this makes no sense. Oh God. Now, I'm going to go ahead and tell you there are questions that they give y'all that give me a hard time. Okay, sometimes they're, oh God, this is good. This is good stuff right here. This is what's called the difference quotient. And I hate to tell you, but this is your first unit of calculus. So if you suck at this, you're going to suck at your first unit. Difference quotient. Now I'm going to explain to you what the difference quotient is from a calculus perspective. So therefore, I'm killing two birds with one stone. All right. I'm showing you a little bit of unit 1 here. So, Mr. Cobb, do you have a question, or did you forget to take your hand down? Okay. All right. That was funny. Okay. All right. So I'm going to draw, I'm going to go back to algebra, and I'm going to draw a BA graph. Okay. Y'all know what a BA graph is. That's a big attitude graph. So here we go. Here is a big graph, the first quadrant. There we go. And I'm going to put 2 dots on this graph. You can draw them anywhere, because we're going to make up some numbers to put. No, we're not going to make up numbers. Well, yeah, not right now. And I'm going to take my handy dandy ruler, and I'm going to draw a line between those 2 dots. Now, if I was to do this with numbers, let's say I'm going to go ahead and kill 3 birds with 1 stone. What do you mean 3 birds? Well, the first bird I'm going to kill is slope. That's in R4, I think. Okay. The second thing I'm going to kill is difference quotient. And the third thing I'm going to kill is composition or substitution. Composition / substitution. So we're killing 3 birds with 1 stone. So the first thing I'm going to do is I'm going to do the review on slope that's in R4, and we're going to calculate the slope here. Let's say this is 2, 4, and let's say this is 6, 8. Okay, I want everybody to try to remember as much as you can about finding the slope of this line and try to do it. I'm going to give you a minute. If you can't do it, just consider yourself a failure. Okay? Can y'all do that? Consider yourself a failure? Give y'all a minute. Or, I'll tell you what, let's make it 30 seconds, since I already gave you like 15 seconds talking.
I can't see the number. I can't see the other coordinates. I don't know.
Sorry. I suck.
He did that on purpose.
Yeah, I did. Or he did. What, are you saying that I did it on purpose?
Yeah, you're sabotaging.
I know. I'm that type of person.
Hubert's the imposter.
I'm like your other teachers. What'd you say, Miss Hollister?
It's a game that everyone plays, and you like sabotage the other people in the game.
What's it called?
It's called Among Us.
There you go. There's a minute. All right. Now remember, slope is equal to delta y over delta x, which means y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Which way do we read? From left to right, unless you're from the Middle East, Masalama. Okay? If you're from the Middle East, you read from right to left, but this doesn't apply because I'm going with the majority. We go from left to right. So this is x sub 1, y sub 1. This is x sub 2, y sub 2. So parentheses minus parentheses over parentheses minus parentheses. That would be 8 minus 4 over 6 minus 2. 8 minus 4 is 4. 6 minus 2 is 3. So 4/3 is your slope. Y'all check my math, make sure I didn't mess up. Okay? So that's how you get the slope. Now I'm going to go ahead and kill another bird right now. Since we're in review, I can do this. All right? Another bird I'm going to kill is the point slope equation. Now the point slope equation is y minus y sub 1 equals m times x minus x sub 1.
Wait, sorry. I think your math's wrong.
That's the point slope equation. So you need to write that down. I'm sorry, say it again.
Your math might be wrong.
What?
I think 6 minus 2 is 4.
And I think you read a 3 when it's a 2.
I love how, see how Miss Hollister does that? See, that's the female thing. That's the female gene. All right. She makes it out. You know, I think 6 minus 2 is 4. And I hate to tell you, Miss Hollister, but that was a wife gene right there. I'm sorry.
Definitely.
Okay, shit. Okay. I believe 6 minus 2 is 4. Where Mr. Abdallah and Mr. Palmer were kind of suggesting that, she just comes on out and says, I believe 6 minus 2 is equal to 4. Like, okay, yes, ma'am. All right, so here we go. Now I want you to pick a point. I'm going to pick 2 and 4 because we always like to deal with smaller numbers. So y minus parentheses equals m parentheses brackets x minus parentheses. My y sub 1 is 2. My slope is 1. And my x, I'm sorry, I just screwed that up. That's a 4, sorry, and that's a 2. And now you just simplify this. Y minus 4 is equal to x minus 2. Y is equal to x. Negative 2 plus 4 is 2. And that is the slope. I meant the equation for this line with a slope of 2. I'm sorry, of 1. So we killed 2 birds with 1 stone right there. We got 2 more to do. Okay, so that is, this comes out of all this right here that I just did with numbers comes out of R4. Okay, so I just did 2 parts of R4 for you. Okay, now I'm going to apply what we learned right here, especially this right here. I want you to draw this. I'm going to draw it on the next page because we're going to use this in the difference quotient. All right, so I'm going to go to the next page. Leave that up for a couple of seconds more. And I'm going to draw another graph. And I'm going to draw 2 points. And we're going to talk theory here. Theory meaning I don't have numbers, okay? And I want to find the slope, but I don't have numbers. So what are these points called? Well, this point right here, if I was to, let's see, let's take the color green and directly down here, and I draw a line directly down here. And for each x, I have a corresponding y. We'll go with this lavender. And right here. Now, somebody tell me what this first green spot is right here. What's down here? It's not a number, it's what? X, Hubert. That's right, class. Thank you, my former Math 109 students that should remember. Thank you. Then what is this? Well, this over here is going to be f of x. Now, between here and there, I'm going to take another color and we're going to color it orange. And we're going to call it, we're going to temporarily call it D, but we don't use D, so we're going to call it something else. This right here, between these 2 x's, you usually consider it D for distance, right? But we're not going to call it D, we're going to call it H. There are some books that call it D. There are some books that call it delta. All right, so some books call it D, Some books call it delta. Get used to that delta because you might see delta again in other books, especially, well, that's mostly engineering, I'm sorry. But delta is used instead of D in this, and some books use H. Most books use H. So what is this second green spot right here? My 109 students should be answering these questions. What is that second spot, this second green spot? What is it? X plus H, Hubert. That's right, class. So somebody tell me what this second blue spot, lavender spot is.
Is it H?
X plus H.
F of what?
Plus H.
There you go. Okay, now this is where I want y'all to be smart. I want y'all to tell me the slope of this line using M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'll even do the parentheses for you. Now, instead of numbers, you're going to put in these green and purple places, okay? So go ahead and do that. Go ahead and plug and chug and simplify. Give you about 30 seconds to do that. And if you need to, I'll even go further. I'll even help you out a little bit more. Let me find another color. Let's go with a pink or mauve. It looks like pink with the cap.
Hubert, we appreciate your colored pens.
Thank you. That come out of the left field, but thank you. This point right here is x, comma, f of x. And this point right here is x plus h, comma, f of x plus h. Now, there's your two coordinates. Now, I want you to take those two coordinates, and I want you to plug them into the slope formula, and I want you to reduce it or simplify it. There's only like one thing you can do to simplify it. There's not a lot. So go ahead and plug and chug. There's another hint. Now, if you can't plug and chug now, I don't know what else to do. I mean, I've given you like 3 hints. Give you a few more seconds. Okay, so tell me what goes in this first parenthesis right here. That means I want somebody to talk.
F of x plus h.
F of x plus h. Okay, what goes in this one?
F of x.
And what goes in this one?
X plus h.
And this one?
X.
Now, what's the only simplification that can be done?
Subtraction.
Anybody know?
You get h by itself on the bottom.
Yep. The x's do what?
Cancel
Subtract.
out.
You cancel. So you're left with, and we're going to write this in red because this is important. M is equal to f of x plus h minus f of x over h. So I've taught you how to go from pre-algebra to fancy hold your pinky up f of x. Now I'm telling you that the slope is not, that the difference quotient, I can't spell, is nothing but what? I underlined it for y'all to say it.
Slope.
M. It's slope. Difference quotient is nothing but the slope. Hold your pinky up. Because you're basically telling me it's a slope. Now, in calculus, this h is going to decrease. Okay? Because what they want you to do, and I'm just throwing this in for your information. Unit 1, I'm going to take yellow markers. I'm going to highlight these two. And instead of a straight line, you're going to have a curve. And that curve is going to look something like this. Okay, there's your curve. Now, if I want to find the tangent line of this curve, like there, I've got to bring this point close to this point. So that means that this h is going to decrease. And when this h decreases, you're basically talking about limit as h approaches 0. Now, in unit 1, we're going to take this and we're going to apply the limit as h approaches 1 to this difference quotient. We're going to take limit theory and algebra and mash them together, and that's calculus. And that's what we're going to be doing. Now, that kills the second. What does that do, Hubert? Well, that tells us what the difference quotient is. The difference quotient is actually the what? The slope. There's two ways to write the slope. The first way is the redneck way. There's the redneck way. Now you're sophisticated, and now you write it like that. This is for functions. This is for numbers. And I guarantee you there's somebody out there that's never made the relationship between slope and the difference quotient. It's the same thing. This is for numbers. This is for functions. Don't you feel good about yourself?
Yes.
Now, what's the third thing? Composition slash, or fourth thing, because point slope, we did that. Composition substitution, and that is the homework question that we are at right now. I'm trying to find it. There it is. There is our question. And they're basically saying, find the slope of the line at any number of negative 3x minus 2x minus 1. So I'm going to rewrite the problem. You know, the things I do for y'all, I tell you. All right. So, f of x is equal to negative 3x squared minus 2x minus 1. And that is the function. That's f of x. So that f of x, we'll go ahead and write our quotient m is equal to f of x plus h minus f of x over h. Now I'm going to add some color to this, and I'm going to take my pink highlighter and I'm going to color f of x pink. And I'm going to color x plus h orange. Ugh, they clash. Anyway, what does it mean when you have something in parentheses with a function? What does that mean? What does it mean when you have a 4 in the parentheses of a f of something? What does that mean you do with that 4?
You plug 4 in for x.
Okay, so what does x plus h in parentheses mean?
You plug x plus h into x.
Into the function, right? So
Yeah,
I'm going to
it's function
rewrite f of x. I'm going to rewrite this function with black numbers, but I'm going to use orange for the x's because I'm going to plug that in wherever there's an x. Okay, so I'm going to rewrite. It's going to be m is equal to -3, -2, -1, and I'm going to plug in right here, parentheses squared, parentheses, and I'm going to put all that in brackets. And I'm going to plug in x plus h right here. And I'm going to plug in x plus h right here. And I've just done that right there. Now that's the part right there that people screw up on. This part right here is where people screw up. And then I'm going to subtract pink brackets. That's more like mauve, but and what goes in f of x? Well, the function f of x. F of x is this function. So -3x squared minus 2x minus 1. And all that is over what? H. Now, do the algebra. Remember me telling you if you sucked at algebra, you're going to suck at calculus? This is the first part of Unit 1. What we are doing right now makes up a good part of Unit 1. So make sure you learn how to do this. All right, give y'all about 30, 45 seconds to work with that. Not that you finish, but at least get it started. And if you can't, just consider yourself a failure. And you should probably quit school and get you a nice cardboard box somewhere. What do you think? Nobody's going to talk to me. That's fine.
All right, I've went through it, but I'm pretty sure I'm wrong, so I'm ready.
Okay. Yeah, I could tell you pretty much you're wrong. I'm just kidding. All right, first thing I'm going to do is I've got to address this quadratic right here. And that is shortcut number 1.
Crap.
Let's jump over here. Let's jump over here and let's redo our shortcuts. Let's go through it right quick. The first shortcut is a plus b quantity squared is equal to a squared plus 2ab plus b squared. 2a minus b quantity squared is equal to a squared minus 2ab plus b squared. 3, a squared minus b squared is equal to a plus b times a minus b. 4, a cubed. I always get this one mixed up. Yeah, a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And 5, a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Now, most of the time when you're dealing with these, you're going to be dealing with these first two right here, shortcut number 1 and shortcut number 2. But everybody in the classroom should be saying to themselves right now, oh yeah, I remember those. Okay? If you're not saying that, then you need to go to my Math 110 or Math, 110, I guess Math 110 or 109, and you need to go back over some of these in the review in those Math 110 and 109s. Or send me the questions if you run into one. All right, so this one looks like A. That x plus h quantity squared looks like that, which will give you this. Now, if you aren't fluent in what I'm fixing to write down in these shortcuts, then that means that you pretty much suck at algebra and you need to get with the program. So that means that this orange quadratic is going to go to x squared plus 2xh plus h squared with a negative 3 in front of it. And we are going to distribute this, but I'm not going to do it yet. And that's x plus h minus 1. And all of that is still in orange brackets because we're still working with this first part right here. Now, you can go ahead and distribute this negative if you want to. And we're going to get, I wish I had a better, I guess I'm going to have to deal with this because the only other color I got is salmon. So salmon. You got to say salmon. You can't say salmon. S-A-M-M-I-N. That's wrong. You got to say salmon. Anyway, plus 3x squared plus 2x plus 1 all over h. Now we can distribute that negative 3 and that negative 2. Now that I'm getting closer to the end, I'm going to start coloring everything black because I'm distributing that negative 3 and that negative 2, and I'm going to just make everything black again. So that's going to be negative 3x squared minus 6xh minus 3h squared minus 2x minus 2h minus 1 plus 3x squared plus 2x plus 1. Now, a lot of you may be thinking at this point, oh my gosh, how do you get all that? Well, everything's going to cancel. all the x terms are supposed to cancel. Now write that down in your notes. 90% of the time, all the x terms will cancel. 90% of the time, most of the x terms will cancel. You might be left with 1, but most of them are going to cancel. Let's look. Let's take our red marker out. Is there a positive 3x squared anywhere? There it is. Is there a 2x and a negative 2x? Oop, there it is. Is there a negative 1 and a positive 1? Oop, there it is. That's supposed to happen. So now M is equal to negative 6xh minus 3h squared minus 2h over h. Factor out a h, and that's negative 6x minus 3h minus 2 over h. The h's cancel, and you're left with negative 6x minus 3h minus 2. And that's your answer. So let's check it. Negative 6x minus 3h minus 2. And you feel good about yourself. Now I'm going to show you what this means. And that's going to be a little bit of Unit 1. Okay? And I know that I'm running out of time, so, well, I'll tell you what, I'll just wait and do that later. Okay, so that's how you do that problem. And hopefully that'll help Miss, oh, hold on a minute. Homeland Security Department number 2. Got to log out every 15 seconds. Let's see, y'all are 1:30. That'll help Mr. Abdallah and Miss Hollister. That help y'all?
Yeah, definitely, for sure.
Miss Hollister?
Yeah, I'm good. Thank you.
Okay, so that moves on to number 75. This is number 75/19. And I will tell you, that problem we just did, you can mark that down as a test question. You'll see that at least 3 times on my test. So what are you going to have to work on besides careless mistakes? Time. You're going to have to get it to where you can do that pretty fluently. The amount of money in a savings account is, okay, this is interest. This is a calculator drill. A is equal to P, 1 plus R over N raised to the NT power, where P is equal to the principal, how much money you're putting in the bank. R is equal to the rate, which is in a decimal form. Oops, I'm sorry. There we go. This is a calculator drill. I think I already said that. N is equal to the number of times compounded in the year. And T is number of years. Now I want to put this note. If you ever see it on a standardized test, 6 months. Somebody tell me what 6 months is. It's a half a year, right? So a half a year would be 0.5. So if you ever on a test and they say you put the money in the bank for 6 months, you don't put 6 for t, you put 0.5 for t. 3 months would be 0.25. 1 month would be 1 over 12. So make sure you make that distinction. All right, so now we just plug and chug. What do we got? 0.04%. So 0.04. And compounded quarterly, so n is equal to 4. 9 years. And how much money did we put in? 6,000. So 6,000. I'm just going to write it, and then we're going to work it on a calculator, because there's no reason to write anything else after you write the initial, because you do it all in the calculator. 1 plus 0.04 divided by 4 raised to the 4 times 9, which is what, 36? And now we go to the handy dandy calculator. Now watch how I punch this in, because this is the way you're supposed to do it. So I'm going to give everybody a second, because we already called the roll and I got 3 minutes. So I can get finished with this and everybody won't be doing funky chicken on the floor going into convulsions. I got to put my markers up. All right, everybody got their calculator out? Here we go. What do you do first? Well, you always work your way inside out with your, sorry, let me clear this for the video. There we go. All right, you always work your way inside out with parentheses. So 0.04, and y'all all know that 4 cents divided by 4 is 1 cent. But we're going to do it in the calculator just for giggles. Okay, that's 0.01. We're going to add 1 to that, and that's inside the parentheses. And then we're going to raise that to 36, caret symbol right here. Caret symbol looks like a upside down V. 36, enter, and multiply that by 6,000. And that is how you do these types of problems. Like I said, it's a calculator drill. So by the end of 8 years, or however many, 9 years, you're going to have $8,584.61, which is a profit of $2,584. That means you've got $2,584.61 that's paid in what? Interest. Okay. So how much money round to the nearest cent? So that would be $8,584.61. And I want to mention this to you. If you're interested in doing a business type math like this, we offer 103, and it has a section of this along with mortgage payments, credit card payments, and car payments. It's very, very, very beneficial for students to take. I teach it every spring. I'm teaching it this spring. It's unit 3. So if you want to go in and look at my videos, find the 103 and go to unit 3, you'll see more of these. So you can figure your car payment, you can figure your house payment, and at the end of 20 or 30 years, whatever, you know how much you've put into it by interest, and you know how much you've put in it as far as principal. Okay, so that takes care of 3 questions. So I'm going to delete this question, and I'm going to delete the 59, and that leaves next time we'll do 77, right? And that'll be from Miss Hollister. Let's see what that one is just right quick before. I know y'all gonna have fits. I know. Let's see. That's plug and chug also. 184 centimeters tall. That goes in for H. And weight is 75. I'm gonna do it on a calculator right quick. Let me make it smaller. Okay. Move down. Okay, height is 84. So that's going to be 184 clear. So that's going to be 184 times the weight is 75.
You have a work email.
Divide by 3,600. I believe we might have to do some unit conversions on this one, but I'm going to go ahead and see. And you're going to take the square root of that. So that means raise it to the 0.5 power. 1.957. I think we're going to have to make, yeah. The reason I don't like this, what is the height is in centimeters, but what is the square what? Meters. I think we're going to have to do the unit conversion on this one. I don't think 1.95 is correct. I think it's going to have to be converted. Yeah, it's going to have to be converted. So we'll have to convert it. We'll wait and do that one when y'all come back. So we're going to leave that one on the books. Anybody got questions? Everybody feel good about themselves? Or do you feel worse than when you came in?
We're good.
If you feel worse, then I've done my job. All right. What should you be able to do right now? Well, I pretty much covered R2. Okay, when I did all that stuff, you should be, over the weekend, you should have R2 either completed or you should have R2 75% completed with questions sent to me. All right, y'all have a good weekend, and I will see y'all Tuesday. Okay?
Yep.
See y'all. Be good. See you later.